I'd like to talk to you about SMED, single minute exchange of die, a technique developed by Toyota after the Second World War to reduce setup times. And the reason I want to talk to you about it is because there's still the perception that it's mostly pertinent to the automotive industry, when this is not the case. I had recently somebody from the aerospace industry saying, no, we don't need to use SMED here because we're in the aerospace business. We calculated together the setup time in their factory with 40 very, very expensive machines, and it was 30% of the OEE. And so they agreed that if we could reduce by half the setup times in their factory, which we did easily, then that would increase by half of 15% the output, which it did. Okay, so that's what I wanted to talk about. I won't go through the details. There's plenty of good books and videos about how you do it. Let me just remind you what you usually do today is to film, because it's so cheap to do. You just film the operation, and then you have a group of people watch the film, take it apart to try and work out how you can do things better. Some of the simple tricks are to do stuff, prepare the work before, or find things that you can do separately, standardize some tooling, replace screw nuts by clamps and stuff that can go very quickly and stuff like that. Right? It's all that is easily described, well described in books and videos and stuff. So just go ahead and do it. Okay. Now, what's strange is that Marris Consulting still does a lot of SMEDs, or rather helps its clients do a lot of SMEDs now, 70 years later, and that's not normal. It should become part of practices, whatever your business, right? Whether you're in the food processing industry, the pharmaceutical industry, aeronautics, or whatever, right? It's a universal truth. It's all about spending the same kind of brain time, mindset time on not only on productivity, the time per parts and stuff, but on setup times. Spend as much time trying to optimize those as production time. That's what Toyota did. That's what it realized. Okay, and if you do that, you'll find that you can easily reduce by 50% the durations. Right? Don't get obsessed by the name SMED, single minute exchange of die, because that means you're trying to get to less than 10 minutes, right? 9 minutes or less, one digit, 1 minute. So if you're starting off with 3 hours, do a SMED which aims to get down to 1 hour, right? That's going to be a first step in the right direction. And then little by little, you do another and yet another. And later on, in 10 years' time or whatever, you might get down to significantly reduced numbers. But the idea is to get started and to work hard on it. Okay? When you do this, right, it's kind of different when you do it on big, expensive, complex machines rather than on the machine where the technique was born in the press shops making car doors and stuff like that in Toyota, right? So let's imagine you're talking about, I don't know, a paper machine or corrugated cardboard or a rolling mill for steel or these sorts of huge machines, right? When you do a SMED or you want to reduce the setup times, it's different because one, unfortunately for you, it's going to cost a bit of money to do it, right? A traditional SMED on a manufacturing machine, you can do a very good one and spend nothing or 5,000 euros for a bit of tooling or whatever, and it'll be done. On a huge rolling mill, you might have to spend 50,000 euro on some tooling and stuff, so it's going to cost you some money. The other thing is that you're probably going to have to consider it as a mini project, right? Because you've got maybe 15 people working at different parts of the machine, and they have to work in a certain sequence for mechanical reasons and for safety reasons, right? And so it's worth really making sure that everybody knows what the right sequence is that you're aiming for, and proper communication between people. I've done this, okay, you can do that, carry on. That's one other thing to take into account. And secondly, in these processes, what I find very surprising is very often at the end, when you've done all the changing of the tooling and the nuts and bolts and stuff, all the mechanical part, you turn it on, right? You're meant to get the first part coming out good, right? But you don't. You have to tweak the settings, the temperature, the speed of this, the pressure of that, or whatever, right? And while you're doing all that, you're wasting time and money, and that's not good, okay? So if you're in that case where there's maybe a third of your time or a significant proportion of your setup time is this tweaking setup adjustments, right? That's a good opportunity. It's a little worrying because it means you don't actually know what the perfect settings are to produce something, but it's a good opportunity to improve significantly, because if you do some kind of design of experiments, or think hard about how you're trying these different adjustments, do it in an organized way so that you find the standard adjustments that enable you to get the product right first time. And that will not only shorten that tweaking time, right? It will improve your mastery of your quality, reduce your scrap rates, and enable you to much better understand your process. So that's if you've got that, deal with it, and you'll find you're going to learn a lot of things and become a lot more masterful in managing your process. Okay.